Yacc part. So before going to Yacc part, let me consider one example with respect to lex. Okay, so you just concentrate here. The first section you are supposed to write is definition section. So this program, see, there is a question like it goes like this: write a lex program to identify identifiers. So if I give a input file wherein I have written identifiers, then your lex program, you have to write a lex program in such a way that it should identify the identifiers. Okay, so let's see this code now. So it has to it should have three sections. One is this one is definition section, right? And this part we call it as rules section, and the last part, this we call it as auxiliary subroutines, or you can say user code. You can say, or you can call it as user code or C code, right? In the first section, which is definition section, where I'm going to write the required header files, right? So with respect to this example or the program, I declare this header file, that is stdio.h. Okay, and I have used one more variable here, that is count. So this variable counts the identifier that represent in the given code. Okay, and I'm initializing it to 0. See, this part you have started in C language, right? First header file I have written, and then the required variables. Okay, and this part I have written it in definition. Okay, after definition, the second part, and do remember the definition part start with percentage immediately followed by curly brace. Okay, and it should end with percentage immediately followed by right curly brace. Okay, and then rule section, so it has to start with delimiter, that is percentage immediately followed by percentage. In the next line, you have to write the regular expression and what action it has to take, that you are supposed to write. See here, the given question is you have to find the identifiers, right? Isn't it? So if I enter a code like this, A plus B in my C program. Say C is a high level language, right? So in C language, I'll just write it as A plus B. So when I give this as input, then what it has to recognize? It has to recognize this as an identifier and B as an identifier, right? So to find the identifier given in the input, I have to write the regular expression. So how do you write the regular expression? See, I can see this A and B are nothing but variables, you can say, right? So I can declare the variable in C language either like this A, or I can write it as underscore A or underscore A followed by the number and so on, right? So to match this identifiers or the variables, I am writing the regular expression like this. See, my identifier can be only A, right? So that can be matched with this regular expression, see A, okay? Or if I write the variable or identifier as underscore, starting with underscore symbol followed by alphabet and followed by a number, right? Even this is also proper way of declaring a variable or identifier, right? So this can be matched with this regular expression, that is underscore. See here, underscore is there here, followed by an alphabet. See here, it can be this alphabet or this, and followed by the number. Even I have written the number here. Okay, so if I enter this kind of variable or identifiers in high level language, it has this, to recognize this, I have to write the regular expression in such a way that it has to recognize these variables or identifiers. Okay, so this writing this way of regular expression will help you to identify these identifiers which you have written in a C language. Okay, so when this matches with this regular expression that says this, yes, these are the identifiers. Then when it recognizes this identifier, it has to count it. Okay, it has to count it. Okay, so then after that, what if I have written any printf statement in my program? Okay, that will be matched with this dot operator. When printf and all other get ch, or if you have written stdio.h header file, then those will be matched with this dot operator. Okay, so when it matches with this or dot operator, what is the respective action it has to take? I have written it as semicolon, which says do nothing. Okay, it matches the all leftover code in the C program. Okay, and that it matches with the dot operator when it, yeah, if any other statements are written in C code, that will be matched with this dot operator. Okay, and the respective action taken is nothing. Okay, this is what the work that has been done in this rule section. Okay, next, after in C code, what we will write, we will call yylex program, sorry, yylex function. So this function, yylex function, will, when this line is executed, the control will, this function will check the rule section that you have written in lex program. Okay, so when input is given to this lex, it will check the regular expression. Yes, the given identifier matches with this regular expression, then it takes the respective action, that is, it counts the identifier. Okay, once it completes the scan and considers the action part, then the control will come to this next part that you have written after lex function. So what you have written? I've written print whatever the count value is there here. Okay, so it will print the count value of the identifiers that are present in C program. Okay, this is how you write a lex program for the given question, which includes all the sections that we discussed so far. So in the definition section, you will write the header files and the variables, and in the rules part, you will write regular expression and the respective action. And at the C code or the user code section, you will write yylex function. Okay, this lex function will scan the regular expression and it takes the respective action for the same. Okay, this is how you're going to write the lex program. Fine. So next we'll move on to the next topic, that is Yacc. Okay, so as I discussed in the as we discussed in the syllabus, the Lex and Yacc program you are supposed to write for the given program, given question in the syllabus, right? So Lex is about lexical analyzer, that is the first phase of the compiler design. Okay, the second phase of the compiler design is parser, right? So that we are going to discuss it now. So Yacc is yet another compiler. Yacc stands for yet another compiler. So now what is the work of this Yacc? Again, Yacc is a tool, or you can say it is a program which generates a parser. Okay, so generates the parser in the sense which is the second phase of the compiler design, right? So yet another compiler, it is a programming tool which generates the parser, which is nothing but the second phase of the compiler design. Okay, now see, I said lexical analyzer generates tokens, right? Right? That is the output of first phase. So this token is given as input for the second phase of the compiler design, that is parser. Now you can say here, Yacc accepts the token from the lexical analyzer and checks whether input is syntactically correct or not. So the output of Lex program is always tokens, right? So these tokens are given as input to the parser, which is nothing but which is generated by the Yacc, and it will check whether the given input is syntactically correct or not. So this is the function of the second phase of compiler design. Okay, and this parsing is can be done either top down parser, or you can follow bottom up parser. See, top down parser and the bottom up parser you are going to discuss in the theory part. Okay, I'll not discuss this part in the lab because you are going to study this part in the theory classes. Okay, so let's see the structure of this Yacc. Okay, so one second. Structure of this Yacc. So you write the Yacc program with the extension .y. That is file name followed by .y. Y says it is a Yacc program. Fine. So Yacc program is compiled with the help of Yacc compiler. Okay, and it generates a C program always. Okay, in the case of Lex, it will generate yy.lex.c, right? When you compile a Lex program, it generates C code in the name yy.lex.c, right? Whereas here, with respect to Yacc program, when it is compiled by the Yacc compiler, it generates y.tab.c. Okay, since it is a C code, again we are feeding this, or we are going to compile it with the C compiler. Okay, so C compiler compiles it and it generates the output file as a.out. Okay, so this is the parser now. A.out is the parser, that is output file. For this a.out, we are giving input for this. Okay, so this input generates the output, which is nothing but it says whether the given input is syntactically correct or not. Okay, a.out is a parser here, please do remember, and input is the tokens that is generated by the first phase, that is Lex. Okay, this is the structure of Yacc program. First we will write Yacc code, and the extension of the file is filename.y. Okay, and then it is compiled with Yacc compiler. The output of Yacc compiler is always C code, that is y.tab.c, and this C code again compiled with C compiler, which generates the output file as a.out. For this output file, we are going to give input, and it checks and gives you the required output. Okay, so input for parser is always tokens, which is generated by the Lex program, or you can say lexical analyzer. Okay, this is about the structure of Yacc. Fine. Next, we'll move on to the next slide. That is how to write a Yacc program now. Even for this also, we have a structure to follow or a format to follow. Again, this consists of three sections: definitions, rules, and user code or C code. Fine. We'll see one by one. That is definition section. The first section here again, the required header files are the variables that we are going to discuss, and under declaration or definition section, we are going to define the tokens, right? These tokens which the Yacc program, the tokens which are generated by the lexical analyzer will be given as input for parser, right? So what are the tokens that we are going to consider in the Yacc program? That definition is required. Okay, see, if I'm using two tokens as an input for my Yacc program, then you have to define those tokens in the Yacc program. Okay, so that is that we call it as definition of tokens, and you have to specify the token in the form of percentage followed by the word token. Token, it is a keyword here. Do you remember? We are going to declare the header files, and the required variables in the definition section of the Yacc program. After this, we have to mention the tokens that we are going to use it in the Yacc. Okay, so that you have to define those tokens in the definition section, and that you have to do it by following the syntax, that is percentage followed by the keyword token. Okay, we'll see an example for this later. Okay, and then second, if any operators we are using in the program, then their associativity must be specified. See, in mathematics, or if you consider any operator in C language, each operator has its own precedence, right? Each operator has its own priority. Either it may be left associativity, or it may be right associativity, right? So in the same way here, if we use any operators in the Yacc program, then their associativity you must specify. You have to specify whether it follows left or right. Okay. So this is one more thing you have to remember while writing definition section. And next is rules, right? Next part is rules. Yeah. So under rules section, we are going to write a grammar. Okay. Grammar is what? Which is a series of rules that parser uses to recognize syntactically valid input. Okay. The function of parser is to find out whether the given input is syntactically correct or not, right? To find out this, you are supposed to write a grammar under the rules section. So now the rules section, you are going to write the production in this way. I mean, what action this specifies the grammar and what action need to be taken for this grammar that you are going to specify here. And this production should be terminated with semicolon. Please do remember the production you have to write and the respective action you have to mention, and this grammar should be terminated with semicolon. Okay, this is the sentence you must follow. Next, the third section is C code. So in C code, you are going to write YY parse function. So in the Lex, while writing Lex program in C code, you will write YY Lex function, right? So in case of Yacc, in the C code, you are going to write YY parse function. Okay. So what does this YY parse function does? Now, see here, see when this YY parse function is called, it will check the productions that you have written under the rules section. Okay, and while checking the production, you have to refer the tokens. Okay, tokens which are generated by the lexical analyzer. Okay, so let me consider this diagram, then you will understand the working of YY parse. Okay, so consider this. This diagram says the communication between Lex program and the Yacc program. See, with respect to Yacc, I said the rules grammar will be written, right? And under the third section, that is under C code, you are going to write YY parse function. Okay, see when this parse function is called, it will check the grammar. Please do remember, it will check the grammar written in the rule section. Okay, when it checks the rule section, it has to refer the tokens. Okay, the tokens where it is generated in the lexical analyzer, right? So when the parser checks the grammar, this in turn checks the token which is generated by the Lex, that is YY Lex function. Okay, so here this will refer the required tokens here, and it will check the input, that is tokens. If it is written syntactically correct, then it will give you the parse input for the next phase of the compiler design. Okay, so one more diagram I considered here. See here, I said when you compile the Yacc program, you will end up with C code, right? That is y.tab.c, isn't it? So again, you're going to compile this, right? Again, you're going to compile this, then parse will be generated. For this parse, it has to get the tokens from the lex. So when it requires token, it will call the lex function. The lex function will return the tokens for parse. Okay, and then the required output will be generated. So I'll just brief you out what and all happens when you are asked to write a program uh, to find something or to calculate something. First thing is what? First, we will write the lex program. Please do remember first, because we need tokens for Yacc, right? So you're going to get the tokens only if you write the lex program, right? Lex code generates the lexical analyzer. Lexical analyzer generates tokens, okay? And these tokens can be given to the Yacc to check this whether the input is syntactically correct or not, right? So first, the lex program will be written, okay? In this case, at the C code section, you will call lex program. This lex program will check the rules given here. See, so when the input is given for this lex, it will check the lexical rules or the regular expression that you have written. Okay, and if it matches, it will take the required action and it will generate tokens. Okay, now when it comes to the parse function will check the grammar rules written. If it matches, it will consider it considers the token that is generated by the lex. If the tokens are properly generated, then it will says the given input is syntactically correct. Okay, this is how the flow goes. So any doubts till this point? Anyone? Any doubts?
No.
Okay, I hope this part is clear. See, if you understand the working of Lexine Yacc, then only you will understand the code. If I start explaining the code, then it will be more clear. Okay, okay, then no doubts, right? So next part is how to execute Yacc program. Okay, the same command. Okay, I have to. Okay, so there's a mistake here. No, okay. See, first you have to compile Lex program, right? That's why I have written here. Lex filename.l. Okay, this is the first step. And then compile the Yacc code, that is Yacc command followed by -d, then filename.y. Okay, and then link lex file with the Yacc file. So that you are going to do it by compiling lex.yy.c and y.tab.c. Okay, you're going to link these two and compile it, and then you will get the output file, and you're going to execute with the help of /a.out. Okay, these are the commands that are used to execute Yacc program. See, when I say write a Yacc program to do so and so, then you have to start with Lex program. Please do remember, because input for the Yacc is token, right? The token can be generated by the lexical analyzer. So how do you generate lexical analyzer? By writing a Lex program. Okay. So that's why you have to start with Lex program.